And now, to give us a perspective from space, please welcome the John and Adrienne Mars Director, Smithsonian National Air and Space Museum, Ellen Stofan.
Good afternoon. I'm Ellen Stofan, the John and Adrienne Mars Director of the Smithsonian's National Air and Space Museum. It's great to still be able to carry on with our Earth Optimism Summit at this difficult time, as the world comes together to address one truly global crisis, and we work hard to confront this threat. Perhaps we can learn some valuable lessons for how we can work as one on the crisis of global climate change. And if there's one thing that we keep hearing about as the foundation for addressing COVID-19 that's equally applicable to climate, it's having the data to make sound decisions. When Apollo 8 took the first humans to the moon and gave them that amazing view back at our fragile blue planet, astronaut Bill Anders said, "We came all this way to explore the moon, and the most important thing is that we discovered the Earth." While his words are poetic, we'd actually started discovering the Earth from space more than a decade before. The very first humanly built heavenly body, Sputnik, in 1957, transmitted radio signals that the Soviets used to measure the ionosphere. 3 years later, the US launched the first satellite built specifically for Earth observation, TIROS-1, taking a huge step forward in weather forecasting. As the sophistication of our technology to study our home from the ground, air, and space has grown, so have our earthly challenges. Initially, we wanted to know the fundamentals of how our planet worked. What we've now learned is that we are changing those fundamental processes, altering over the course of decades systems that have developed over millions of years. So we need even more and better data, consistent data, to address that impact. As a planetary geologist, as in planets other than our own, I have to mention that we also add to that knowledge by looking outward, by studying our neighbors in the solar system, to understand the basic science behind how planets work. And that feeds back into the questions that we ask and the data that we collect to help us find answers. Unfortunately, the data that we continue to gather on our one and only home is frankly grim. We have found time and again that things are moving in the wrong direction and faster than our predictions and models have told us that they would. That can make it hard to be optimistic. But I grew up in a part of Ohio where a major river caught fire and Lake Erie was declared dead by some. Facing those realities helped begin the movement 50 years ago that we're celebrating now. And today, the river and the lake have been at least partially restored. It is possible to change course and stem the tide of environmental damage if we confront the challenge head on. That's why I'm optimistic. We know that with informed, unified, innovative action, we're capable of anything, including saving the beautiful spaceship Earth that is our unique home. I believe that the growing volume, better quality, and more definitive data we're gathering today by NASA and NOAA observing Earth from air and space can have the same galvanizing impact. So let's take a look at the amazing evolution of how NASA has looked at and learned about ourselves from high above.
Just prior to the subsolar point on the south side and the floor of it, in the evening, there is one dark hole. Oh my God, look at that picture over there. There's the Earth coming up. Wow, is that pretty? beautiful shot.